I saw this one. The integral of 2 over e to the minus x plus 1 dx. Any thoughts?
Well, we gotta get u equals negative x.
You can let u equal negative x, but all that's going to do is it's going to change this to e to the u plus 1, and then we'll need a minus out here. So it's not bad. I don't think it's... It certainly doesn't allow us to answer the question yet. Other good ideas?
And if we let u go to negative x, we can derive it just going to x back. So that's an example.
Well, my initial guess would be, quite often, u is the bottom, correct? The issue is, if I then do du, I have negative e to the negative x dx. That doesn't seem to help a whole lot. Because, do I have an e to the negative x up here on top to work with? No.
Multiply the top and bottom by e to the negative x.
Multiply the top and bottom by e to the negative x? Then what am I going to do with that e to the negative x that's down on the bottom here?
And then become e to the negative 2x. And then e to...
Okay, but then I'd have this. I'd have an e to the negative x times this 1 still. I got to distribute. Other clever ideas. No, it actually can be solved.
Is it u substitution?
It is u substitution.
U substitution.
No.
I mean, we have to do like say multiply by e to the x over e to the x, but I don't know if it really helpful. We're looking at the hyperbolic function. So similar.
What'd you just say to do?
Multiply by e to the x over e to the x, but then we have the e to the x on the top.
That was not my answer, but that will work.
So what works?
Wouldn't lie to you.
You still have the e to the 2x plus e to the...
All right. Well, let's try his way. I like his answer.
Well, I don't know what to do with it, but it looks close.
His answer
Change it.
is to multiply top and bottom by e to the x. So I'm going to have 2e to the x. And then what am I going to have on bottom? What's e to the x times e to the negative x?
1.
1, because you'd add those, that would be e to the 0. That's 1 plus e to the x dx. Of course, this 2, I can just take out front, right? But now look what happens if I let u equal 1 plus e to the x. Du happens to be e to the x dx, and now I have an e to the x on top. So it works out very nicely. So this becomes 2 integral 1 over u du. That's 2 ln, absolute value of u, plus c. So that's 2 ln 1 plus e to the x plus c. How was I going to do it? I was going to make it a lot harder.
Why would you do that?
Well, because sometimes you don't see the easy way. Here's what I was going to do. I was going to factor that 2 out. And then I was going to say, you know, this u substitution almost worked what I really needed up on top was I needed an e to the negative x. So I was going to put an e to the negative x up on top. So I was going to write 2 times the integral of 1 plus e to the negative x. But I can't just put an e to the negative x on top. The penalty is I have to subtract an e to the negative x all over e to the negative x plus 1. What was I going to do next? I was going to split the numerator. I was going to split it right here. So I'm going to have 1 plus e to the negative x divided by e to the negative x plus 1. So I got to take the 2 along with me. The 2's multiplied by everything. So I was going to split it right here. I was going to split it into this part minus that part. What's 1 plus e to the negative x divided by e to the negative x plus 1? 1. So I was going to end up with integral of 1 dx plus integral negative e to the negative x over e to the negative x plus 1. I could pull the negative out, or I can leave it right there because it matches perfectly with my du. So this becomes 2 times, what's the integral of 1? X plus the integral of 1 over u du. And I didn't leave myself enough room, so I'm going to come up here. So that's 2 times x plus ln of u, but here my u was e to the negative x plus 1 plus c. That was going to be my way. What's interesting about doing that problem 2 different ways? We got 2 answers that don't look alike. Somehow they must be equivalent. That's correct. Are they equal? No. Somehow the constants must be different. So that was really about the only thing that I saw new in this. I thought the only thing I saw new was having to do that trick where I have to add and subtract something on the numerator. But it turns out you can do this one a different way, and I think your way was easier. Multiply top and bottom by e to the x, and then it's a simple u substitution problem.
So how did you, when you multiply e to the x times e to the negative x, that equals 1?
Yes.
E to the 0.
Because when you multiply e to the x times e to the negative x, when you multiply things, you add the exponents.
Yeah.
So that's e to the 0, which is 1. Those cancel each other out.
And we kind of did the same thing in that one question that I had. 2x plus minus 4.
Correct. We were kind of doing the same thing in that question you asked me, where we had to add and subtract. That question was out of 5.7, add and subtract something and then split them. And I thought that was the first time it showed up was here in section 8.1. I don't remember seeing it back in the other sections.
Found it.
You found it. It was in there somewhere. All right, so that's all of 8.1. 8.1 was easy. It's just all review, which gives us time to start section 8.2. All right, so what we're going to learn in Chapter 8 is we're going to learn a bunch of new integration techniques. At this point, the only thing we really know for integration is u substitution. We do u substitution, and we hope it fits one of the forms we know.
Is this integration by parts?
Section 8.2, we're going to learn a new technique called integration by parts. That's correct. All right, so when we did derivatives, we had the product rule, the quotient rule, and the chain rule. U substitution is the reverse of the chain rule. Chain rule and U substitution go together. They both deal with compositions of functions. Integration by parts is kind of the reverse of the product rule. All right, so it comes from the product rule. So let's say I wanted to take the derivative of a product. And we usually use the letters U and V. I'm not sure why, but those are the ones always used. What would the derivative of U times V be? Where U and V are not constants, they're functions of some sort.
U times V plus.
I'm going to write it as UV prime. And actually, I'm going to write it this way. I'm going to write it as V du plus U dv. So I'm going to use that little d symbol for derivative. So good? All right, so now I'm going to take this equation right here, and I'm going to integrate on the left, and I'm going to integrate on the right. What happens when I integrate on the left? What's the integral of the derivative of u times v? U times v, because integrals and derivatives are inverses. They cancel each other out. So if I integrate both sides, put a big integral symbol here, I get u times v equals integral v du plus integral u dv. And so here's the integration by parts formula that we use. It's usually written this way. The integral of u dv equals u times v minus integral v du. All right, so the important thing is you see you have u times dv. You have multiplication. So this integration by parts formula is almost always used in problems that involve multiplication. So for example, I might give you the integral of x times ln x dx. You see right there that you have multiplication, x times ln x. That's a very good indication that you probably want to try integration by parts. So what you need to do integration by parts, you need to pick something to be u, and then everything left is going to be dv. So you got to make a guess. U is either x or u is ln x. Anybody got a preference? U should be ln x?
Yeah.
Okay.
X is a derivative, simple.
Okay. So you're going to guess that u is ln x. You're going to sit back and watch. And then dv would be everything left. So what's everything left? X dx. All right. Then, to use this formula, I need to know u. Do I know u? Yes. I need to know v. To find v, I integrate dv. So v is 1/2 x squared. And then I need to know v. Do I know v? I do. And I need to know du. Do I know du? I derive u. So du is 1/x dx. All right, so here's my answer. The integral of u dv, this was u, this was dv, is u times v. U was ln x. V was 1/2 x squared minus the integral of v which is still 1/2 x squared, times du, and du is 1 over x dx. Well, you know you're on the right path if this integral over here is now something you think you can take care of. Can you integrate 1/2 x squared times 1 over x dx? And if so, how? I'll give you a hint, it's not a u substitution problem. X squared divided by x is just x, isn't it? So you simplify there. So this is, I'm going to write this as 1/2 ln x, 1/2 x squared ln x, minus, I'm going to take that 1/2 out and simplify inside. When I simplify inside, that just becomes x dx. Can I integrate x dx? I better be able to. Final answer is 1/2 x squared ln x minus 1/4 x squared. Because I'd have a 2 and I'd have a divide by 2, combine my terms there, plus c. Questions on that? Should we prove it? How could you prove it?
Well, by deriving.
You could take the derivative of this and show that you get x times ln x.
Would you get an equivalent answer?
No, you will get it exactly. Because when you take the derivative of this constant, it's going to be...
If we chose u to be x, the x is just x, would you get an equivalent answer?
Oh, I see what your question is.
If you had chosen a different...
What if we guessed the other way? Good question. Let's try it. Integral of x ln x dx. So this time you want to choose u to be x and dv to be ln x dx. So I'm going to write our formula up here so we remember what it is. Integral of u dv is u times v minus integral v du. All right, so to use this formula, I need to know u. Do I know u? U is x. I need to know v. Do I know v? Integrate it. So v would be the integral of ln x dx. What's the integral of ln x dx? No, that's the derivative. The derivative of ln x is 1 over x. What's the integral of ln x? We do not know. That is the correct answer. So what does that tell you? You made a bad guess. That's right. Right there, that's a huge indication that...
Well, usually it will be towards the beginning that you say, okay, we can't do that one yet. And usually go all the way through to figure out, you know what, this just isn't right.
It varies. This one, you come up right away, you see, I can't do this. This isn't going to work. Let's try another one. How about x times e to the x dx? Any guesses for you? It's either x or it's e to the x. Which one do you like? E to the x. U equals e to the x. Which means dv is everything left, which is x dx. All right, so again, to use my formula, I need to know u, which I always know, and then I need to know v. In order to find v, I need to integrate. So what's v? 1/2 x squared. And then I need to know v, which I already know. And finally, I need to know du. So I derive. So du is e to the x dx. All right, so this becomes u times v. That's e to the x times 1/2 x squared. Minus integral of v is 1/2 x squared, du is e to the x dx. At this point, I look at this and I say, I made a bad guess. What's that? In fact, we're even worse than where we started, aren't we? We started with an x dx. Now I've got an x squared dx. The power got bigger even. So that's an indication that I made a bad guess. I'm about where I started, but in a sense I'm even worse. My power got bigger. That's a bad thing. So that tells me we made a bad guess. So what do? We say, ah, crap. Luckily, there's only one other option, so we start all over again. Oh, I didn't say that. I might have implied that, but I didn't say it. So u should be x, which means dv is e to the x dx. So du is 1 dx, and v is e to the x. So my integral, x times e to the x dx, becomes u times v. u times v this time is x e to the x, minus integral of v, which is e to the x. That looks much better, because now I have something I know how to do. What's the integral of e to the x? E to the x. So my final answer is x e to the x minus e to the x. Let's see. All right, well, I have good news for you. The good news is there's a little trick for guessing what u should be that almost always works. It works probably 99.9% of the time. And I don't think there are any problems in your book where it doesn't work. So the little trick for remembering how to pick for u is I late. But you're not late for your math class. I stands for? No, it's a type of function. Inverse. So, if you see your integral, and your integral has an inverse trig or an inverse hyperbolic, that is your u, every time. L stands for? Log. So if there's no inverse trig function, the next thing to look for is a log. That should be your u. A, that's the hardest one. A is algebraic. What's algebraic? Like an x plus 1, or an x squared, or in this case that we just did, the algebraic was just x. T? Trig. And E? Exponential. Which I spelled wrong. So that's the order that you look for. Okay? So exponential comes last, so we definitely should not have let u be e to the x. Comes last. All right? We will do some more of these on Monday. And then you're going to take a test on Tuesday, correct?